Hi everyone, I am going to start a new course called TOC, Theory of Computation. This subject is one of the most easiest subjects compared to all others. Why I am telling you that this is most easiest subject? Because even a 10th class student can understand these subjects very well. Okay, without knowing any basics. And second reason is in GATE exam, this is the most scoring subject. It means in every year they asked from these subjects about 8 to 10 marks. Okay, and this is one of the most easiest subjects. So if you go through my lectures, you will be definitely able to solve all GATE questions of this subject. Okay, why I am telling you this? Because I will going to do a lot of examples, a lot of solved examples and all every previous questions of GATE exam and also every theory. Okay. So if you go through my lectures, you will be definitely very good in these subjects. Okay. So TOC means theory. T means theory, O means of, and C means computation. Okay. By this name, you might be thinking that this subject is something about computation. But in GATE exam, it is actually a theory of computation, but in GATE exam, they rarely ask any theory about these subjects. They mainly focus on problem solving questions. So I am going to do a lot of problems on these subjects. Okay. So you might thinking that this subject is something about computation, and a computation means any task that can be performed by a machine or a calculator or a computer. That is called computation, right? So we are going to design a mathematical model. We are going to design a mathematical model, and after designing the model, we are going to study theory about it. Okay, so I am going to start this subject from the beginning, from the basic. So focus here. In TOC, Theory of Computation, the basic starts from symbol, and symbol is a smallest building block. A smallest building block. Okay, and the symbols are nothing but any alphabet, so on, any digits, 0, 1, so on, even a human being images. Okay, this is nothing but symbol, and from symbol we can form alphabet, and alphabet is denoted by sigma. This sign is called sigma, and sigma is nothing but, means alphabet is nothing but collection of symbols. Collection of symbols. And one more point about alphabet, it is always finite. It can't be infinite, it is always finite. Just remember it, okay? It is always finite. Okay? So collection of symbol means sigma can be A or B. It is nothing but this alphabet is a collection of English letters, English small letters, okay? Or sigma can be 0, 1, okay? This alphabet is nothing but collection of binary digits. Binary digits means 0 and 1. Or sigma can be 0, 1, 2, 3, so on 9, and this alphabet can be decimal digits from 0 to 9. Okay, this is nothing but alphabet, and from alphabet we can form called a string, and a string is denoted by W, and a string is nothing but finite collection of symbols, finite collection of symbols from some alphabet, means sigma. What does it mean? Finite collection of symbols from some alphabet. It means, see that. So just make a note of it, and I am going to erase it. And if you don't understand anything, just pause the video, go back and rewind it. Okay? So finite collection of symbols from some alphabet. Let's alphabet is A comma B. Okay, and then strings became A, B, AB, AA, BA, BB, AAB, ABB, AB, AB, triple A, triple B, something like that. Anything. A combination of A comma B, because it is over this alphabet. Okay? So see that the definition: finite collection of symbols from some alphabet, and some alphabet means it is A comma B. Finite collection of symbols. It is nothing but collection of symbols, each one, and each one is finite. Each one is finite. Okay? So this is the meaning of definition. And one more thing, it is nothing but length. These both are length 1, these fourth are length 2, and these are length 3, these are length 3, and these length are 4, so on. Okay, so we do this later, but till now just know that what is a string. Okay, now I want to, let's sigma equal to A comma B, and my question is what is all the strings, means set of all strings of length 2 over this alphabet. Okay, so what does it mean? It means I want all strings of length 2, which means 2 length. Okay, and these 2 spaces can be filled with A or B. It means this space have 2 choice and this space have 2 choice, right? So totally these spaces can be filled by, there are 2 spaces, and these both can be filled by either AA, AB, BA, BB, right? So totally 4 strings: AA, BAB, BA and BB. Totally, so set of all strings of length 2 can be 4. And also this space has 2 choice, this space have 2 choice, 2 into 2 equal to 4 also. So if we want this, extend this question. Okay, set of all strings of length 3. So I just extend this question. Set of all strings of length up to 3. Exactly 3. So there are 3 blank spaces. So because I want length 3 strings, and each strings can be filled with either A or B, right? So this can have 2 choice, this can have 2 choice, this can have 2 choice. Totally number of strings can be 8. 2 cross 2 cross 2. 2 to the power 3 means 8, right? So what are those strings? Can you imagine? Length 3, okay? So starts with AAA, AAB, ABB, okay? ABA, BAB, BBA, BAA, 1, 2, 3, 4, 5, 6, 7 and triple B. Totally 8. These are all 8 strings. So set of all strings of length 3 can be 8. And what are those? These are. Okay. Make down a note. Now just extend this question a little bit more. I want set of all strings of length not 2, not 3, length n. Okay, I want just set of all strings of length n. So there are totally n space, 1, 2, 3, 4, so on n. Okay, and each space can be filled with either A or B, either A or B, either A or B, either A or B, so on. So this can have 2 choice, 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 so on n times, right? So 2 cross 2 cross 2 cross n times, which is nothing but number of strings can be 2k power n. Okay. So when this sigma is a comma b, if sigma can be a, b, c, there are 3 symbols in that alphabet. So what happens? There are n spaces, so on n times, and now each space have 3 choice, either A, either B or either C. Each have 3 choice, each have 3 choice, each have 3 choice, which means n times. So totally 3 to the power n number of strings. So set of all strings of length n, if sigma is this, then number of string is this, and if sigma is this, then number of string is this. Okay. Make a note of it. I am going to erase it. Next thing is language. What is language? Even a English language is nothing but collection of words, right? But in TOC, a language is nothing but set of strings, over some alphabet, right? So language can be finite, empty, infinite. These 3 types of language. So language is what? Set of strings of any length over some alphabet, and it can be finite, empty or infinite. So let's do some examples. Let sigma equal to a comma b. Okay, and language L1 is set of all strings of length 2. Okay, set of all strings of length 2. So this language contains what it can be, length 2, which means over this alphabet. So AA, AB, BA or BB, right, over this alphabet only, of length 2, not length 1, not more than length 2, only exactly length 2. So this language is nothing but finite language. Why finite? Because number of terms in this language is finite. So language L2 equal to, another example, language L2 equal to set of all strings which starts with a letter A. Set of all strings which starts with a letter A over this alphabet. Okay. So this language contains what it can be, A, AB, ABB, AA, ABA, ABAB, ABBBB, so on. And this language nothing but infinite language. Infinite language. See, this language, what is the question? Set of all strings which starts with A. Starts with A, 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 ending with A or B, we don't care. But it has to starts with A only. Okay. So number of terms is infinite, that's why language is infinite. Okay. And empty language can be represented by this. This is nothing but empty language. Okay. And next thing is powers of sigma. Powers of sigma. What does it mean? Let's some sigma equal to A comma B, and I want to show you different powers. Okay. So starts with 0, sigma to the power 0. What does it mean? It means set of all strings of length 0. Length 0. So what can be there? Length 0. So length 0 means 0 length string, and that can be represented by a symbol called, this symbol is called epsilon. EPISILON. Epsilon. Epsilon is nothing but 0 length string. Remember that. Epsilon is nothing but 0 length string. Next thing is sigma to the power 1. So sigma to the power is, what does it mean? It means set of all strings of length 1. So length 1, the strings are A or B. Why? One length string, one length string. Okay. Sigma to the power 2. Sigma to the power 2 means set of all strings of length 2. Okay, so sigma square means sigma concatenated with sigma, and sigma are a comma b concatenated with a comma b, right? And it can be a concatenated with a concatenated with b, b concatenated with a, ba, and b concatenated with b, bb. See, each one is 2 length. My question is also length 2. So similarly we can find sigma cube, sigma to the power 4, so on. Okay, but I want to find out sigma star. Okay, make a note of it. I want to make sigma star, okay, over this same alphabet. Sigma star. It is also called clean closure. What called? Clean closure. Okay. So what does it mean? Sigma star means in place of a star we can put any number including 0, which means we can put here 0, 1, 2, 3, 4, so on. We can put any number including 0. And one more thing is there, sigma plus. Okay. The main difference between both is we can put any number here also, but excluding 0. Which means we can put here 0, 1, 2, 3, so on, but here we can put only 1, 2, 3, 4, so on, not 0, which means 0 is allowed here and 0 is not allowed here. This is the main difference. Okay, so how to find out sigma star? Sigma star means we can put any number in place of a star. Sigma to the power 0 union, sigma to the power 1 union, sigma to the power square union, so on infinite times. Okay, so sigma to the power 0 means what? 0 length string means epsilon union. It is nothing but 1 length string a comma b union. It is nothing but 2 length string a ab, ba, bb union, so on, right? Here 3 length string, next 4 length string. So this sigma star contains everything. Which means, see, 0 length string, 1 length string, 2 length string, so on, 3 length string, so on, 4 length string, so on. So this sigma star is called universal language. Or complete language. Or it is also called superset of all languages. Or every language is a superset of. So next thing is there is a question in my mind or in your mind. The question is, where can these symbols, these languages, these strings can be used in practice? Which means, why I am teaching you these symbols, these strings? Where are these symbols, strings, languages are used in practice? See, that I want to represent you a simple example so you can understand the application of these symbols, languages. Okay, so consider a C programming language. C programming language, right? So the input alphabet for the C programming language, when we make a C program, then we can use some alphabets using keyboard, right? And that alphabets can be all letters A to Z, right? All capital letters A to Z, right? All digits 0 to 9, or plus, minus, multiplication, division, modulo, so on. Finite, not infinite. Finite, because sigma is always finite, and number of keyboards in our PC, our computer, is finite. So, and consider a simple program, okay, like this: void main function int a equal to b equal to 20, int c equal to a plus b. This is a simple C program actually, but this program is a combination of a collection of these alphabets. So for the TOC, this C program is nothing but a string for TOC, right? For the TOC, this program works as like a string, right? So what is C programming language? C programming language is nothing but set of all valid programs, right? Okay, so it means it is a combination of P1, P2, P3, so on, Pn, infinite, right? So C programming language can be set of all valid programs. There are these all valid programs, infinite. Okay. Now there is a question. Let's say a program called PX. And it is a valid program or invalid program. How do we know? Let us a random program PX. How do we know that this program is valid or invalid? Okay. So the simplest solution is that save all these programs in our computer. These all programs, since these are valid programs, and save all these programs in our computer and compare this program with each one. P1 with PX, P2 with PX, P3 with PX, so on. And if there is a match, then we say that this PX is valid, and if there is no match, then we can say that this is invalid, right? But the problem is, since our computer has limited memory space, limited hard disk capacity, right? So how can we store infinite number of programs? Are you getting my points? Since our computer has limited memory, limited hard disk capacity, either 500 GB, 1 TB, 2 TB, limited, okay? So in limited memory space, how can we store infinite number of programs? This is the main problem, right? So whether a string belongs to a language or not, in that application, in that thing, these symbols and these languages are used in practice. What does it mean? It means to check whether a string W belongs to a language or not. How can we check? See, let us say sigma equal to a comma b, and language L1, and let us say any string W b a b, right? Any random, just as sake of any example, a random string b a b, and language L1 is set of all strings of length 2. Length 2. So L1 contains, what contains? AA, AB, BA or BB. Now my question is whether this string W belongs to this language L1 or not. So since the language is finite, you can say easily yes, it belongs to this language, or no, it not belongs to this language. Since the language is finite, we can easily compare, right? In 4 times we can compare and say no, this string is not belonging to this language. But when the language is infinite, let's see what happens. Language L2 is set of all strings which starts with A. So language L2 contains A, AA, AB, ABA, ABB, AAB, so on, infinite language. And see, each string starts with A, right? So now question is whether this W, this string, belongs to this language L2 or not. So since the language is infinite, we can't able to compare. How many times you compare? Compare 1 times, no match, no match, no match, no match, no match, no match. How many times you compare? Are you getting my point? So the intention of this, that if language is finite, then it is easy to say that a string belongs to that language or not. It is easy. But when the language is infinite, it is not easy, or it is impossible to say that whether a string belongs to that language or not. Okay? So what is the solution of this one? The solution of this problem is, problem with, why we don't come up a finite representation, okay, that can be stored in our computer and which accepts language L, and when we give any string to this machine or this finite representation, this machine is able to say that yes or no, which means there is a finite representation that represents language L. L is finite or infinite, doesn't matter. Okay? And when we give any string to this one, this machine is able to say that yes, this string belongs to that language, or no, this string not belongs to that language. It is a better solution, right? So this finite representation is called finite automata. Finite automata. Sometimes it is called acceptors. So what is finite automata and its various types and a lot of examples on finite automata in next class. Okay? Till now, just know that what is symbol, what is alphabet, what is a string, what is language, and what happens when language is finite, what happens when language is infinite, powers of alphabet. Okay? That's all. Okay? So, meet you in next lecture.